Over the next decade, India is deploying $50 billion to build an entirely new industrial backbone, pouring capital into semiconductor plants and battery gigafactories. Retail investors often try to capture this momentum by chasing consumer-facing electric vehicle brands or waiting for the eventual microchip manufacturers to go public. Meanwhile, global supply chains are actively fracturing. International legislation like the U.S. Inflation Reduction Act strictly mandates that manufacturers source critical materials outside of restricted nations to qualify for consumer tax subsidies. Building a mega facility to meet this new demand takes years. Before a single commercial microchip or battery is sold, billions of dollars are spent laying the physical groundwork. Institutional capital is targeting the highly specialized manufacturers operating entirely behind the scenes. These companies control the infrastructural choke points, effectively taxing the entire ecosystem during construction. To understand these choke points, look outside. A modern semiconductor plant consumes millions of liters of ultra-pure atmospheric gases continuously to keep the environment stable. Linde, India designs and operates massive cryogenic air separation units directly on site at major high-tech hubs, like the massive Tata facility emerging in Dalera. This dual timeline chart illustrates the structural advantage of an infrastructure provider. On the top timeline, Linde locks in 15 to 20-year take-or-pay contracts, generating guaranteed revenues starting at year 0. On the bottom timeline, the fab itself won't record commercial revenue for another 4 years. By supplying the literal air the factory breathes, the gas provider secures a captive monopoly long before production begins. Beneath the pristine manufacturing floor is the subfab, a dense labyrinth handling the highly toxic, explosive specialty gases required to etch silicon. Navigating this hazard requires Honeywell Automation India. They deploy the critical digital nervous system, utilizing hyper-accurate 13mm pressure sensors and multi-point gas detection grits. The stakes here are absolute. A microscopic leak of nitrogen trifluoride halts production immediately, ruining millions in delicate silicon inventory and endangering the entire facility. Because this zero-tolerance sensor network is built directly into the architectural foundation, the software acts as a permanent operating system, generating reliable maintenance revenue for the life of the plant. Moving the chemicals themselves presents another severe engineering bottleneck. The extreme acids used to carve sub-nanometer transistors would dissolve standard stainless steel piping in minutes. To prevent the metal from leaching contaminants, the entire fluid delivery system is lined with advanced fluoropolymers. Gujarat Fluorochemicals produces PFA and PTFE, highly inert, temperature-resistant plastics designed specifically for these caustic environments. A single fab requires thousands of meters of this indestructible piping, alongside specialized valves and storage tanks, purchased and installed during the early construction phase. Supplying the physical immune system against the factory's own corrosive chemistry guarantees the manufacturer captures a massive portion of the initial capital expenditure. Up inside the cleanroom, the environment must be devoid of particulate matter. Workers operate in full isolation to prevent contamination. Inside the enclosed machines, advanced photolithography uses extreme ultraviolet light to print patterns onto the silicon. This requires highly specialized, light-sensitive liquids called photoresists. Acutus Chemicals is currently the sole Indian manufacturer capable of producing these ultra-pure, semiconductor-grade photoresists, actively breaking into a market historically dominated by Japanese incumbents. A single stray metallic ion in the chemical solution can cause stochastic defects, resulting in line-edge roughness that destroys a billion-dollar batch of wafers. Mastering atomic-level chemical synthesis creates immense pricing power. Once a fluid is validated in the production recipe, fabs rarely risk altering it, locking out competitors. Step into the battery Gigafactory to find a similar chemical bottleneck. The highly sensitive liquid electrolyte is the vulnerable heart of the battery cell. Neogen Chemicals produces the dominant electrolyte salt, LiPF6. It is exceptionally volatile. Exposure to trace amounts of moisture causes it to rapidly decompose into deadly hydrofluoric acid, which shreds the battery's internal components. By utilizing technology licenses from established Japanese joint ventures, Neogen bypassed decades of research and development, instantly entering early-stage validation testing with major global manufacturers. Solving the Gigafactory's most dangerous chemical hurdle early ensures the supplier's proprietary recipe is embedded deep within the battery's core design before mass production scales. These 5 equities operate within a strict matrix. They manage highly hazardous chemistry, endure brutal multi-year validation cycles, and offer a localized supply chain that satisfies strict geopolitical sourcing mandates. This split-screen chart illustrates the resulting compounding curve. On the left is the volatile price action typical of a consumer hardware brand fighting in a crowded market. On the right is the smooth, upward curving cash flow of an upstream chemical supplier. As the initial capital expenditure finishes and these megafabs turn on, early investments scale aggressively into high-margin operating leverage. In an industrial gold rush, the most consistent returns belong to the enterprises engineering the ultra-pure, zero-failure pickaxes. True technological sovereignty takes a decade of physical construction. The bulk of the economic value is captured precisely at the invisible, unbreakable choke points of the supply chain.